Hi friends, today I am going to discuss randomness and probability. So, probability is a quantification of the likelihood of a specific event occurring. Like suppose I am tossing a coin and there are two probability. One is the half probability like a heads comes and like a half probability like a tail comes. So we use a probability institutively all of the time, all through the sometimes the formal theory can be quite uh, like a counterintuitive. So probability theory aims to describe the behavior of random variables whose value is not known, but where the probability of the value is this random variable taking some values is known. So these probability are usually in the form of one of the several probability distributions. Now we will see probability like a more applied setting, like something working with the data and statistics. But here just I will discuss like in this the randoms items at a randoms and generating a random data, changing the random numbers generators, generating a normally like a distributions random numbers. So I'm using a Google Colab platform and just I am applying probabilities like randoms and others with the Python's language. Python is a very powerful language. Just if you don't know about like a Python's, so we can see my previous video. I think 2 and 3 day back. You can see my video like I have already make all these things. So let's see just there is some technical requirements, and just one technical is like we required the pymc3 package for the final like install in this package. So I have already installed pymc3. So how do, if you are using like a Google Jupyter notebook, so you need to write here exclamation sign and like this pip install pymc3. And actually this package pymc3 provides the facility for probabilistics programming, so which involves the performing of many calculations driven by randomly generating a data to understand the likely distributions uh, of solutions to problems. And after that we will import like a import numpy is the numericals, just we have already discussed. Another from a numpy import a randoms, because we will generate a randomness value, numerical value, and import the pymc3, just we have already discussed. So import, and from numpy random import default rng. So these four library, and in future we will also discuss like a more library. So these four are the most important. So first I am going to like at the core of probability and randomness is the idea of selecting an items from some kinds of collections. So as we know, the probability of the selecting an items from a collections qualifies the likelihood of that items being selected. So randomness just describe the selections of items from a collections according to the probability without any additional bias. So the opposite of a random selection might be described as a deterministic selections. So it is a very difficult to the replicates a purely random process using a computer, because a computer and their processings are inherently and deterministics. So we can generate a sequence of pseudo random numbers, and probably the constructor demonstrate a right reasonable approximations and randomness. So first, Python is the standard library, and it contains a module for generating like a pseudo random numbers. So this is called a random. So let's see here the random. This one is a, this is pseudo like a random modules. So this is the module, and the routine where the numpy random modules can use like a generator array of a number random numbers, and slightly the more flexible than their standard library counterparts. So the simple first, before this we now we want to discuss like a one more thing. Just suppose we are tossing a dice, and there is a 6 probability, like 1 2 3 4 5 and 6. So there is the 1 by 6 is the ones probability. Similarly, if you get like a 2 1 by 6. So basic probability we can understand like the probability always the between the 0 and 1. So 1 is called a sure probability, and 0 is called like a null probability, and always you will see like a sum of the probability will be 1. And so you are so look like here, just I am throwing the dice. So there are the simple space. Simple space is a set collections with a no repeated elements, and event is the subset of the simple space. So simple space is the set with the sets, and event is a subset of the simple space. So probability that an event A occurs is denoted like a probability A, and the number between the 0 and 1 we have already discussed, and a probability of the 0 indicates event can never occur, and probability of 1 indicates like a event will certain occur. So whole sample space must be a 1. So when the simple space is described, then probability are just simple between the 0 and 1. So in the case generating a normal distribution, so let's see. First step is the setup the random numbers of generator, and like this is a random number generator. So if I am going to write here, like we will take as a variable any variable. So let's see the RNG as a variable, and I am creating numpy as random in DOM dot default DEFAULT underscore RNG underscore RN default RNG 1 2 3 4 5. So I can write here. So this one has been generated random numbers. So we can see here it has been generated. Yeah, you can see the random numbers, but let's see RNG. So we can see here, but its data is very big. It can select some random numbers. So don't need to see here. It has been generated. Okay, so right. So generated has been generated at this way. Similarly, the changing the seeds for the repeatability. So let's see. Just next we need to create a data and a probability that we will select from. So this step can be skipped if you already have a data stored, and if you want to select the elements with the equal probability. So let's see here. I am going to write here data will equal to np dot arrange ARANGE. So I am going to the arrange this data ARANGE uh, and need to take only the 15. So we can see here like this data. Okay, and I want to see the probabilities, so we write here B probabilities will equal to NP dot array, and I can write it numbers like this. We can also create numbers like this. So let's see here the numbers. Suppose I want to create here, Control C, my data has been created and I want to see like a data. So you could see your data because you have already arranged in this order like 0, 1, 2, 3. So it will be, and similarly we can create your own data like an array formations. So the square bracket has been started like 0.3, yeah, float value just 0.2, 0.1, 0.05, 0.05, 0.05, 0.025, 0.025, 0.025, 0.025, 0.025, 0.025, 0.025. Okay, so 1, 2, and 0.025. So it has been created like a 15. So now we can see this value. So it has been generated like I think 0 0.5, 0 0.5, 0 0.5, 0 0.025. I think just, yeah. So it has been generated my variables. Something has been a mistake here. 0 0.025, 0 0.025 is, so it has been generated. I have gotten the sum. So probabilities, P R O B I P R O B A B I B I L I T I E S N P dot A R R A Y. Okay, So what happens? Something it hasn't been. So Boolean functions and methods object is not subscripted. So np dot array. So I hope it should be created like this in parenthesis, inside of this parenthesis. Now it should be created here. So it's right. Now as the quick, so first we need to create a data and like a probability, and that we will select from. So let's see the assets around the sum of this probability. So if I write here ASSERTSO and round, and now get here like a sum, and again probabilities, and then comma 10, and now we will put here like a twice equal symbol 1.0 comma, and this one, and we can like a probabilities must sum to 1. Like a probability ability probabilities must sum to 1. So let's see what happened. Something, so yes, now the quick test we can use like assertions and probability do like this way. So this is the selections like a data, and p is the probability, and replace like a true. So I have gotten a problem like this 2 1. So sum of 2 1 like this. Don't worry, just we need to forget here like something has been. So second, we can also like create some other value, like we can replace the sum value, like selected underscore array will equal to rng dot choice and data, and this will p will equal to probabilities probabilities replace equal to like a true, comma, size will equal to 5 comma 5. And you can keep here the another brackets. So data just I have already uh, created, but p will equal to probability do not the sum 1. Why I am getting a same problem again? Because I didn't write the sum here. So replace here. So it's not to the sum 1. So yeah, right here just we have gotten here the some error. So we whenever if we added like all these value, we are not getting the sum 1. So we need to the take correct data. So we can easily understand. So we have gotten some problem in our data. So we take like a data. Similarly, just look here. Just I am going to create like another variable. So let's see. Just I create like dist. So first I have gotten r n g dot random, and just I am going to create like a size will equal to 1000. So it has been created, and like we need to the plot like a matplotlib dot py plot. Excuse me. So import plot and third fig comma a. So right here like a fig comma ax will equal to plt dot subplots and parenthesis. So you can see the it has been plotted like a one plot. So let's see, and now I want to plot this data here. So ax dot hist and like a data is dist. So this one look like here. So you could see here the my data has been plotted and data look like this way. So this data has been plotted. So similarly, if you want to like write some title in this data, we could do, let's see, like ax dot set underscore title, histogram. Histogram of random numbers. Random. So you can see your title has been created, and you could see here your title random numbers. So you can see your title look like a histogram and random numbers. But I want to see the something like a add one more thing like a x level and y level like a, so x level. So how do I write here? Ax dot set underscore x axis. So like a x level, do you see here? Yeah, so x level. And what do we want to put here inside of this? Like a value. So put here value. Similarly, I want to also plot like a y level. So ax dot set underscore y level, and y I want to put here inside of this parenthesis like a density. So den density. So look here, just x-axis it has been plotted like a value, and another y-axis has been plotted. You can see your value like this. So this is a way, this is the resulting plot is shown in this figure, and we can understand like so. Let's see the generator and interface provided three simple methods for generating a basic random numbers, not including the choice method that we discussed in selecting items at a random receipt. So in addition to the random method for generating the random floating points number and the integer methods for generating the random integer, so there is also like a bytes method for generating a random bytes. So the integer methods on a generator class combines the functionality of random integers and random integers methods and random states like a old, and we can also change in this method. So from the numpy import randoms, just I have imported, and you can create like a seed square like a random seed sequences, and you can pre-enter some sequences is also very well. And next is the just generating a normally distributions random numbers. So if you can generate like a RNG 1 2 3 4 5, and you can put some value, so it's a, and we can also generate a normal distribution. So let's try how to generate a like a random number. So let's see, just I have already generated here in this figure, so I will discuss here. I have already like a generated this value. So first I am going to RNG and default RNG. So let's see, just from the random and default RNG. So I am going to the create this number like this, and then I try to solve this one. So let's see, just I have taken like this one. default RNG 1245. So default don't need to the here. Default, it's, I think it has been created, so I don't get any problem. Okay, so it has been created, and now matplot I have already imported. So because I am going to the normal methods for our generator instance, so I could write here like a mu will equal to like a 5.0, and sigma standard deviation sigma will equal to 3.0, and another variable sigma like a standard deviation and mu like a mean. Sigma you can put here the like a equal symbol. This is the mean and this is a standard deviation, and after that randomness. So rand, so you can write here rands will equal to like a r n g dot normal and that's parenthesis below c will equal to mu scale will equal to sigma and now size will equal to 10,000. So look here, it has been. Now I am going to the plot like a subplots bins, because I have already created, so I can copy and paste. It's a better like subplots list. So let's see, and okay, so now I am going to copy and paste this one. You can write to yourself also. So let's see the fig AX. I have written fig AX and PLT subplots, and second AX dot hist RANDS. So let's see, I have a data RANDS comma bin. So bins 20, and set a title histogram of normally distribution, histogram of normally distributed data, right? And second is the value and another is the density. Let's see how it's look like this. So I have click here and we can see your data has been created like this. So next we create we plot a histograms of our data, and we have increased the number of bins in the histograms, and it's not strictly necessary for the default the number of the 10 and others. 10 is a perfectly adequate, but it does show the distribution slightly better, right? So you could see here. Now after that we can also define like some Next we can create a functions that will generate the expected density for a range of a value, and this is given by the multiplying the probability density functions for normal distributions by a number we have taken already, samples 10,000. So let's see, just we can define some basic here. Okay, so def normal underscore dist underscore curve, and inside this one is the x. And now I need to write here this one, return like just I have taken a 10,000 number, 10,000, and this one np dot exp minus 0.5 and it will multiply like this one, and x minus mu, we need to put here x minus mu, and this will divided by the sigma, divided by sigma, and outside of this bracket like a 2, and this will be like a divided by parenthesis sigma like a np dot sq rt and twice np dot pi to star np dot pi. So it had been created and look like this. Now finally we plot our expected distributions. So let's see here x range. So I will write here, otherwise you can also treat like a x underscore range will equal to np dot linspace linspa and minus 5 to minus 5 to 15, right? And y will equal to like a normal distribution, so y will equal to normal distribution, normal underscore di distribution score x underscore range, x underscore range, and ax dot plot x underscore range like a y comma k, and you put here these symbols. I hope it has been look like this matplot line and 2D axis, so it has been like this line has been plot like this. So matplot lines 2D, and before that we need to define this value. Okay, it has been plotted. So we can see here our result, and we can create. So if we write all these value together, so we can see your plot here. So this is a way we can easily describe the normal distribution. Like this, and we need to go here like this has been created. So you could see here like this, and so it has been created like this, and we need to put this value again. So we can distribute like some linear space. So I know go here, and we can plot here. So we put here. Now you can see like this, because all values so look like this. So this is the histogram of the normally distributed of this data. So this is the result. So we can see here the distributed of our sample data and closely follow the expected distributions from the normal distributions. Because normal distributions has a probability density functions, like it is defined fx will equal to 1 upon divided by the sigma square root 2 pi e to the power minus 1 by 2 bracket start x minus mean mu divided by standard deviations whole square. So this is related to the normal distributions functions fx according to this formula, and now the fx functions like a minus infinity to the x and ft dt. Okay, so the probability density functions picks at a mean value which coincide with the locations parameter, and the width of the bell shapes is determined by the scale parameter. So we can see in this figure like the histograms of the data generated by the normal method on a generator. The object fit expected distributions very closely. So this is a way we can use here, and most of the time we can also like independent and identical distributions like IAD, gamma functions, beta Markov properties, Markov chains. So we can also do, and it's the better in the future. So basically must we understand like what is the mean. So just if you we are collecting a data, there are three types of data: individual data like 1 2 3 4 5, and second is the frequencies. Just one contains the number of the times, two contains the number of times, three contains the number of times like a frequency, and third is the like a continuous data. We will start from the 0 to 10, 10 to 20, 20 to 30, 30 to 40. This is called a continuous. So basically we can understand how do we get a mean. Some of the observations divided by the number of the observations. Similarly, in the how to solve like a mean in the individual data, frequency data and continuous data. Now the how do I get medians? Like the what happens if you have gotten like the even numbers, if you have gotten the odd numbers, okay. So there are the different processes. Now the modes have some specific formula, and continuous way has a different way. So we try to understand. After that we try to understand like a percentile, quartile, okay. So quartile means like a 1/4 quartiles, okay, 3/4 quartile, like a 25% quartile, 50% like a city's median, and but 75% quartile. Similarly the percentiles we also try to understand, and after that we try to understand like a standard deviations. How do we get a standard deviations, and then we can get a variance also, and then we will come at this point and try to understand. But after that we have to understand like a statistics, like a t statistics, f test, chi-square test, okay. So these are also the most important. Then we have already discussed like a correlation, so you try to see in the some video. Otherwise I will make some specific video for the correlations, because after correlations we will start like a data science time series analysis, okay, and the regressions analysis, okay. So don't worry, just today I think it will be the helpful for someone. So today I stop here. Thank you for this video.